Okay, so last part C of the first section, chapter 11. And we have two application questions using some of the knowledge that we've learned. And let's jump right in. So notice the picture here. So what we have is we have an ocean liner, right, that we want to move, right? So we're going to basically be using two tugboats, which are going to apply a force on this ocean liner so that we move it in the direction that we want. Okay? So the question that we have, and most of this is simply given to us in the picture, but we're looking for what the resultant force is of the two tugboats. So we have to understand what we mean when we say the resultant. So recall that the resultant force is the sum of forces. So in this case, we have two forces, right? We have each tugboat is asserting a force. So we have two forces, and the entirety of the question is what is the sum? So F sub 1 plus F sub 2. That is what we're looking for. Okay. So let's get back to our picture here. So looking at our two tugboats, the information that we're given is we're given the angle that theta, and we're also given the magnitude here. So let's start building our force equations. So F sub 1. All right, well, hopefully it makes sense that we're gonna need the magnitude, which is 400. And it's going to be, the only difference here is going to be the angle at which that force is being applied, which is now negative. So negative 20 degrees. So we end up with 400 cosine of negative 20 plus 400 sine of negative 20. And in case it's been a while since you've dealt with odd-even properties, I've captured them here. So the idea of your cosine function is an even function. So the way we can understand that without going into great elaboration is that cosine of negative x is equivalent to just cosine of x. Right? Does that make sense that this negative is not going to play a role here? But sine, which is an odd function, sine of negative x, that negative angle there is going to change, and that is equivalent to negative sine of positive x. So we're going to change these angles into positive 20 degrees, but we have to adjust based on these even odd properties. So let's start with cosine. So cosine is very easy. So 400 cosine. So since cosine of negative 20 degrees is the same thing as cosine of positive 20 degrees, we don't have to adjust any farther. We can just simply turn this into 20 degrees. However, sine of negative 20 degrees is equal to negative sine of positive 20 degrees. So that negative symbol is going to get transferred out front so that we end up with 400 sine of 20 degrees. All right, so here's your vector. Let me go ahead and put my I notation, J notation in here. And here we go. So there is there's your force vector for the first tugboat. Now let's go to the second tugboat, and the magnitude we're told is still 400, only now that we have a positive 20 degrees. So this makes it a lot easier to build. And let me go ahead and do that now. Let me make sure I haven't messed them up. Let's see here. So F sub 2 is negative. I see maybe you already spotted it. All the math that I did was correct. What I didn't notice is that this is F sub 2 and this is F sub 1. I proceeded as if this were F sub 1. So all I need to do is just simply change my notation to F sub 2. Okay. So there's F sub 2. Now let's do F sub 1. Okay, so we got 400. Now that our angle is positive, we don't have to worry about any of those even odd properties. So let's just fill it in. Okay, so we have both of our force vectors, and now we can proceed to add finding the resultant, which is just the sum of them. So what we're going to do is I'm going to so if you recall, when you add vectors, it's component by component. And many of you already spot that this negative 400 sine of 20 is going to cancel this positive 400 sine of 20. But I'm gonna write it for you so that we so that you see it. So we're going to go ahead and add our two vectors. So we're going to have 400 cosine of 20 degrees plus 400 cosine of 20 degrees in the I direction, plus, and this is going to be 400 sine of 20 degrees minus 400. Let me give myself a little bit more space. Let's do it this way, sorry. So that's going to be 400 sine of 20 degrees minus 400 sine of 20 degrees. And now that's in the J direction. Okay. So what I've already pointed out would happen is going to happen. Your sine, basically your vertical direction, your vertical component is going to cancel out, which is exactly what you want if you want your tugboat to move exactly horizontal, right, in this in the horizontal direction. You don't want any vertical component to it. Then you would want J to cancel out so that you're left with just an I component, right? Now that's all vertical direction. I'm sorry, all horizontal direction. So everything is moving horizontally, all horizontal direction. And let's finish it. So if you have 400 cosine of 20 plus 400 cosine of 20, you have 800 cosine of 20 degrees in the I direction. Okay. So notice that so if you want the resultant force, right? The resultant, this is your resultant vector. The force is, remember, a vector has a magnitude and a direction. So the I is the direction. The magnitude is 800 cosine of 20 degrees. So the actual force is just 800 cosine of 20 degrees, which is approximately 752. All right, so I don't know if it tells us what type of units we're dealing with here, but nevertheless, that'll get us to where we want to be. All right, let's move to the next application. And the next application, we're going to do quite a lot of rounding. Normally, I gave you the speech about exact answers, and that is absolutely true, that we're going to you're almost going to always going to express everything in exact answers in this class. The times where you're going to be able to round, right, the times where you're going to be able to do cosine of 20 degrees on your calculator, is when it happens. It's normally going to happen in these word problem application type questions, and that's going to happen right here. So this is a really good problem. So you should take some notes. Let me jump in and start reading. So what we have an airplane is traveling at a fixed altitude with basically no wind factor, negligible wind factor. That's kind of what you're seeing right here. So we have an airplane we have this certain trajectory here, and at no point is it really encountering any wind resistance or wind factor whatsoever. Now, the airplane is traveling at a speed of 500 miles per hour. So there's your magnitude. And this is something that would have thrown me off until I had taken time to learn it. But so the airplane is moving at a speed of 500 miles per hour with a bearing of 330 degrees. And I'm going to take a second to make sure you understand how to read bearings. So you may have seen compasses that look like this. But the idea of bearings, let me just take a quick second so that you understand the question. So normally we begin our angles, so here is 0 degrees, and we travel all the way around till we get back to this point where we have traveled 360 degrees. But when you're dealing with bearings, it's always from the north direction, okay? And we're actually moving in this direction here. So if somebody were on a bearing of 0 degrees or 360 degrees, they would be heading due north. A bearing of 330 degrees would mean that you're going to rotate 330 degrees, just like this. Now, that's fine, except what we're going to need to do in order to make sense of this problem, we're going to have to, let me go ahead and write, bearing of 330 degrees. We're going to have to convert that into a theta. All right, so there's some theta that we want that represents the bearing of 330 degrees. So this bearing of 330 degrees, again, you can imagine, just it's fairly simple to do. You're rotating 330 degrees this way, which you could also arrive if you were to rotate 120 degrees in this direction. So is equal to 120 degrees theta. All right. So let me continue. Let me continue reading. So let's take a quick look at the picture. So now here is the bearing of your airplane. 120 degrees is the theta that we're going to use for our angle, and we also know it's moving at 500 miles per hour. Okay, so it says as the airplane reaches a certain point, it encounters wind with a velocity of 70 miles per hour in the direction of north 45 degrees east. Let's make sure you understand that north 45 degrees east. So the way that you would understand that is, again, if you're here would be your trajectory if you were going due north, but you're from the north, we're going to rotate 45 degrees in the east direction. Does that make sense? Let me draw that. So this, we're going to rotate 45 degrees, and this would be the new bearing of north 45 degrees east. So notice that from north, we're rotating in the east direction. And now this is what you're seeing right here. So you have this wind vector, okay, 70 miles per hour wind, and the wind vector is in the direction north 45 degrees east. So this is hitting your airplane. So at a certain point. Now it should make sense that if this airplane wants to arrive at its destination, it's going to have to account for this wind resistance, right? Does it make sense to you that, like, if you leave, if you leave, I don't know, Europe on a heading towards the Americas, and you're off by a degree, if you're trying to hit New York, you might end up in Florida, right? So that 1 degree of error is going to be problematic over a span of large distance. And so what we want to do is, so now that we have the wind resistance, the question in front of us is, what is the resultant speed and the direction of the airplane? So looking at our figure here, this would be your vector with no wind resistance, but with the wind resistance, it's gonna throw us off course a little bit, and it's gonna change our speed as well. So let's jump into this problem, and the way we're going to do this is let's start by identifying some things. All right, so let's start with V sub 1 is the velocity of the airplane. All right, V sub 2 is the velocity of the wind. All right, so velocity is a vector. So we got our airplane vector, we have our wind vector. Okay, so one of the questions that we're trying to figure out, let me highlight it, is the resultant speed. So the resultant, as you know, is going to be, that's when we're going to find the sum of two or more vectors. So does it make sense that we need to build our airplane vector, then we need to build our wind vector, and then we need to add them, and then we're done with the first part of this question. So let's go ahead and do that now. Let's build our wind. Let's start with our airplane vector. All right. So we're told the magnitude, so we know it's going to be 500 cosine. And I just got done explaining that a bearing of 330 degrees is equivalent to a angle of 120 degrees. And let's go ahead and do the same thing with sine. So that's also going to be 500 sine of 120 degrees. Okay. Let's now build our wind vector. So we're told that the wind is moving at 70 miles per hour. So that's our magnitude is 70. So it's going to be 70 cosine of. And now I'll throw the question to you. What angle do you think we're going to place in here for our wind vector? Right, because we're told it's north 45 degrees east. Well, that's a bearing, right? So we got to be careful. Now, it just so happens that obviously if you rotate 45 degrees east from the north, that's going to be equivalent to rotating an angle of 45 degrees in this direction, right? So in this case only, because north 45 degrees east is equal to a theta of 45 degrees. Normally, you got to be careful, because if this were 35 degrees, you would have to account for that to find your theta. But in this case, it's gonna cut 90 degrees right down the middle. So 45 degrees is what's going to go in here. I just hope it makes sense that this 45 degrees is not coming from here. Okay, it's coming from here. All right. So at this point is when we're going to get a little bit sloppy. Normally what we do in these types of questions is you try to save your rounding to the end, but we're going to just, if we're going to make errors, then let's just do it all wrong. Okay, so I'm gonna go ahead and round now, and this rounding is we're gonna use the rounding in another part of this problem, and you're gonna see how this is gonna we're gonna end up rounding multiple times throughout the problems, because as I said, if we're gonna make a mistake, let's just go all out. Deal? Okay, so 500, so just we're going to go ahead and add. Remember, we're going to add our I components. So 500 cosine of 120 plus 70 cosine of 45. That's going to roughly, I'm going to go ahead and say that's roughly going to be equal to negative 200.5 in the I direction. And now, how do we get our J component? Well, we're going to add these two right here. So 500 sine of 120 plus 70 sine of 45. And that's roughly 482.5. And that's in the J direction. Okay. Now, since we want, so this is our vector, right? So what we just did is we found the resultant vector, but we want the resultant speed. right? So the difference between velocity and speed is obviously speed is the absolute value, right? The magnitude portion of the velocity. So what we want is we want the magnitude of this new vector. This is a vector. We want the magnitude of this vector, and that will be our speed. All right, so we want the speed. It is going to be equal to the magnitude of v sub 1 plus v sub 2. Okay, so you remember how we do this. To find the magnitude, it's just going to be the square root, and we're going to take the I component, so negative 200.5, and square it, plus the j component, which is 400. What did we say? 482.5 squared. So I'm roughly getting 522.5 miles per hour. There's your resultant speed. Okay. So the last bit of information here is we need to find the direction of this airplane. So we have the resultant speed. We just need to find the direction. All right. So I ran out of space. Let me kind of let me go over to the next page. Let me just carry some things that we found. All right. So V is equal to negative 200I. No, 200.5, sorry. I plus 482.5J. And, right, so we'll say V is equal to V sub 1 plus V sub 2. And the magnitude of V we found is 522.5 miles per hour. Okay. So now take a look at our chart here. So we know the length of this vector. In other words, we know the speed. We know the magnitude. What we don't know is the angle, right? Because clearly the angle is changed, but we need to find the new angle. All right, so let me go ahead and get started on this part. So direction of V. All right, well, let's start with the idea that V is equal to the magnitude of V times cosine of theta in the I direction plus the magnitude of V sine of theta in the j direction. And now what I need you to be able to see is we're gonna have to use the information here in order to be able to find that theta. And the way I'm gonna do that is I want to replace cosine of theta with, let me write it for you. Let's see if you can follow me. I'm going to replace that cosine of theta with, I'm going to write it, I'm trying to I'm going to run out of space. So since cosine of theta is the adjacent over the hypotenuse, and my sine of theta is that opposite side over the hypotenuse. Let's let's keep this part in mind. Cosine is adjacent over hypotenuse, sine is opposite over hypotenuse. Let's actually go back to the picture. And now you can think about the right angle being formed here. And what we need is, we can still think about, cosine as being x over the hypotenuse, because this adjacent side would be the x side, the opposite side would be the y side. So the way we can think about this is adjacent is, again, the x length, and the hypotenuse, right? The hypotenuse would be r, right? The radius. Opposite would be y, hypotenuse would be r. I hope that makes sense. What do you mean by r? Well, if you were to make a circle, right? We're to make there's a horrible circle. If you were to make a circle, this hypotenuse ends up being that radius of that circle. So that's what I'm trying to say here. All right. Well, with that in mind, we're getting somewhere. So we're going to replace cosine of theta with x over r. In this case, what would x be? Well, x would be negative 200.5. And what would r be? R would be 522.5. Right, so you notice we're just taking this x and dividing it by its magnitude. Let's do the same thing for sine. All right, and let's plug in. So now we would have 482.5 over 522.5. All right. So obviously, if I plug in the 522.5 here, come back to me. I know you're daydreaming. Listen, I know it takes a while to unpack. Okay, come back. Just put away your phone. Close your tabs. Come back. If you fell asleep for the last 10 minutes, wake up now and you can follow me through the rest. You'll be fine. Okay? Come back. So if I were to plug in 522.5 here for the magnitude, you can see how they would cancel. And what you would be left with, right, is just negative 200.5i, which is exactly what we had. It would be the same thing here with the j component. So now what have we done? This is all of that explanation and work so that I can do this. I can set cosine equal, right? Cosine of theta is equal to negative 200.5 over 522.5. Now, I don't need to do this. You could double check. I only need to do this once, because I need to know what am I even doing? I'm trying to find the direction, right? A direction is a theta. Theta equals what? Well, I can get that from here, right? Don't you agree with me that I have cosine of theta, so I just need to use what? I need to use cosine inverse. So cosine inverse of negative 200.5 over 522.5. Whatever that is my angle. That's my theta. So I'm going to, again, since we're just approximating theta, double check my math. I'm getting roughly 112.6 degrees. You can try that for sine. You would get the same thing. If you set sine equal to what we have here, set these guys equal. So a lot of work, right? It was a lot of work to find this angle. And now I know the angle is 112.6 degrees. So that wind did throw off my airplane, right? Not only did it actually increased my speed. I was moving at 500 miles per hour. Now I'm going 522.5 miles per hour. But it also altered my trajectory. All right, I was moving 120 degrees, and now I'm moving 112.6 degrees. We'll conclude, and I will see you guys in the next video.